Hello everyone. Today I am solving this problem valid anagram. So before understanding the problem statement, let us understand what are anagrams. And suppose we have two strings S and T, and let us say string S is A, B, R, Z, K, and another string is Z, K, R, A, B. Now if we want to see whether T is an anagram of S or not, then in that case all we are required to do is to check whether every character that is present in S is present in T or not. Now it does not matter whether the order is same or different, but the compulsion is that every character that is present in S, we must have the same character for it in T also. And one more thing, if we have multiple instances of some character, that is if we have two A's, then in its anagram or the other string we also need to have exactly same number of instances. So these two strings are anagram of each other. Now all we are required to do in this question is to check whether the given two strings are anagram of each other or not. So the logic to solve this problem is also very simple. We have a string S and it has some characters. So all we are required to do is to actually count the occurrences of each of these characters, the number of their occurrences, and if the number of these occurrences matches the characters that are present in T, then we can say that we have T, which is an anagram of S. So we are going to return either true or false based on the result. And now let us see how we can solve this problem. So we'll start by actually storing the number of each character. We have 1Z, and here also we have 1Z, 1A, 1A, 1B, 1B, 1C, and 2Zs. So definitely S and T are anagram. Now let us see this example. Suppose this string is S and this string is T. So in order to solve this question, the only thing that matters is to know which data structure can be used. And if you know which data structure can be used to solve this question or how you can solve it, then please give it a try. So what I'm going to use in order to solve this question is to actually use an array of integers, and its length is going to be equal to 26 because it is stated in the problem that we have lowercase English alphabets, and I can also use a map as well. And okay, so I'll pass the given string S, and after passing I'll have this kind of structure if I'm using a map. So these are the number of occurrences of every character which are there in this string S, and now all I'm required to do is to pass the string T, and whenever I encounter a character which is there and if it is present in this list, in that case I am going to negate it by 1, which means that we have one character for the current character in the string S as well. So I have C initially, and do we have any occurrence of C? And yes, we had one, and therefore its value become equal to 0. Then I move forward to O. Again its value is also going to be reduced by 1 because it is also present in the given string. So now I have 0 O's in the actual string because I have used this C and this O already. Again I'll move forward to L, and I can see that yes, there is an L present, so it is also used, that is its occurrence become equal to 0 as well. And then I'll move forward to E. Again I have 3 instances of E, and I am going to use one particular character for associating with this E. Let us take any, doesn't matter. The number of available E's are 2 now, and again I'll move forward to this character D. Now I have one D present, and therefore its value changes and becomes equal to 0, and again I'll move forward to this E and then to this E, that is 1 by 1, therefore reducing its value to 0 eventually, and finally I'll move to the last character which is T, and its value becomes equal to 0 as well. So every character that is present in this string is also present in the given string S, and therefore I can say that these two are anagrams of each other. Now suppose that we had 3 or 4 or maybe let's say just one extra character in this string, let us say Z, and finally I'll move to Z, and as there is no Z, it means that the number of Z's are equal to 0, and if I encounter a Z here, then it means that this string is actually not an anagram because there was no z present in the main string or the string s which can actually be associated with this z, and therefore I can say that this string is not a valid anagram. Or we can have some extra characters. Suppose we have another z here. In that case, we must have had 1 here, and if we encountered no z here, then when we are done with this string, then we'll pass this whole map and or array, whatever data structure we use, and if we see that there is some element which is unused, that is its value is equal to 0, in that case also the anagram is not valid. So in that case also we'll return false. So that's how you can solve this question, and now it's time to code the solution. So as I told you, I'll start by making an array. Let us call this AR of length 26. Set all the elements of array r equals to 0 because initially I have no instance of any character, and then for character alphabet in string s, I am going to increase the value of AR by 1, that is AR of that particular whatever that alphabet is minus a plus plus. And what this basically means is, suppose that we have any alphabet, suppose we have C, and if I subtract A from C, then I'll have 2, which is the distance between A and C. So that will be the distance between their ASCII values actually, and at particular that index, that is index 2, I'll store that alphabet C has occurred once, therefore its value increases. And similarly I'll do the same thing again alphabet, but this time I'll take those alphabets in from string t, and this time AR of alpha minus a, again the same thing, but this time I'll reduce them by 1. Finally, when I'm done with this thing, I'll check every element in AR, that is int element in AR, and if element is not equal to 0, then it means that anagram is not valid, and therefore I'll return false. And if we passed all those cases for the 26 numbers, then finally it's time to return true. So that's how you can solve this question, and now it's time to run the code. Accepted and submit. Accepted. So yes, that's it for today's problem, and now I'll see you in the next video. Thank you.